Let us consider the derivative of an odd function and of an even function. If we start with this formula, x to the power of n derivative is n times x to n minus 1. If n is integer, then for even n, this is an even function, and its derivative looks like an odd function. And vice versa, for n odd, this is an odd function, and this is like the derivative should be an even. Is it true also for other functions that are odd or even, that are not in the form of a power? Yes, it is. So let's start. Consider if f is even. A special case of an even function is x to n when n is even, but in general that means that f minus x is equal to f of x. And we want to show that then f derivative is odd. This is easy to show using the definition of the derivative. F derivative at x is the limit of the fraction fx plus h minus fx divided by h for h going to 0. And to show that f derivative is odd, that means f derivative minus x is minus f derivative at x. Let us compute f derivative at minus x. So f derivative at minus x is here, where we substitute minus x instead of x. So we have limit for h going to 0, and instead of x, we write minus x. And the same here. Now, we make use of the fact that the function f itself is even. That means we can change the sign of the argument and the result is the same. So we can change this minus to plus, and we can change this plus to minus, and we can change this minus to plus. And we have the same result. And we want to compare this with minus derivative, minus n derivative. It's similar to the derivative, and we want minus here. So if we write minus h instead of h, the result does not change. So if we change minus h to plus h and plus h to minus h, the result does not change. But then we can factor out this minus 1 in front of the fraction and in front of the limit, and we are done. This is exactly the derivative of f alone, and we have minus here. So indeed, if f is even, then the derivative is odd. And second, if f is odd, that means f at minus x is minus f of x. We want to show that then the derivative is even. That means f derivative at minus x is f derivative at x with no minus. So once again, let's write f derivative at minus x. Which will be limit for h going to 0. And again, we use the definition of the derivative just instead of x we write minus x. Now we make use of the fact that f is odd. That means if we change the sign of the argument, we must change the sign of the result. So if we make this minus to be plus, this plus to be minus, we must write minus 2. And similarly, f minus x is minus fx. So if we change this sign, we must change this sign. And again, we can take minus h instead of h. So we change the sign at h here and here. And then we can cancel minus 1. So this minus becomes plus, this minus becomes plus, and this plus becomes minus. And we are done. This is the derivative of the function f at the point x. So indeed, the derivative of minus x, the derivative at minus x is equal to the derivative at x. So the derivative is even if f is odd.